Okay, this tutorial is based on the AQA Science Physics Core P1.5 unit, heat transfer. There are three main methods of heat transfer: conduction, convection and radiation. Conduction and radiation are dealt with in two other tutorials. This tutorial deals explicitly with the topic convection. The classic convection experiment is where we place either a piece of burning string or paper above one particular chimney and a candle is placed on another. In effect, what happens? The candle warms up the air under the left-hand chimney in this case, and that air rises. Colder, denser air on the right-hand chimney sinks, bringing with it smoke from the burning paper. And what we can now see is a circulation of air with the smoke as it goes down where the blue arrow is, the cold air which sinks, and up with the red arrow, the warm air which rises. And in very basic terms, sort of like grade C explanation, we have the idea that hot air rises and cool air sinks. Convection is a circulation of particles that occurs in fluids, and that's quite important. And a fluid can either be a gas or a liquid. In most fluids, the particles move randomly if there's no heat source, and there's no particular circulation. If we introduce a Bunsen burner on one side, what we find is that the hot air, or the hot water in this case, or the hot fluid, rises on the side where the heat source is, and in this case we have an anti-clockwise circulation where the hot fluid rises on the right hand side, cools, and then sinks on the left hand side. And that will continue so long as the Bunsen burner is working, and that circulation is called a convection current. Again, a fairly simple explanation. Right, what we're now looking at is an explanation with a little bit more detail. What we have at present is just a beak with water in it. We introduce something called potassium permanganate, which is a purple crystal. Don't worry too much about the name potassium permanganate, but the idea of a purple crystal or a dye will help us see, just like the smoke did in the previous example, the circulation current. So what we do is we then heat the water and the crystals. And what happens with that is that the Bunsen heats up the purple crystals. These particles and the water gain kinetic energy and move faster, and the particles get further apart. This causes the fluid to warm and become less dense. So now, as you can see, we're moving into a slightly more detailed explanation, sort of A grade, A star grade. Okay, the cooler and denser water away from the Bunsen now sinks due to gravity, because effectively it's heavier, and that displaces the warmer, less dense water near the Bunsen burner upwards. The warmer water now rises, taking with it the purple dye. And as we can see, that dye then rises. Now on the left hand side, colder water is sinking. So as the water rises, it cools and reaches the surface layer. And what we have at this surface layer, it has nowhere else to go, so it has to go to the left. It then cools. As it cools, it becomes denser and sinks. When it reaches the bottom of the beaker, again it has nowhere else to go, and it goes back towards to replace the less dense warmer water. So it moves off to the right, pushing the warmer water up. That we call a circulation. That is the convection current in detail. So in effect, we have warm, less dense water being displaced by colder, denser water. The warm, less dense water rises, cools, becomes colder and denser, sinks, and goes back in a circulation. That continues so long as the Bunsen is heating the water. So, summary. Okay, top tip. Remember, it's not heat which rises, but the hot, less dense fluid which rises. Key points. Convection is circulation of a gas or liquid caused by heating. Convection needs gravity to pull the cooler, denser fluid down to complete the circulation loop. Heating a fluid causes it to become less dense and rise. Convection needs a heat source and gravity. An interesting little point, if you're in the space station where we have effectively cancelled gravity due to the motion of the space station around the Earth, if you had a heat source, what would happen is the air or fluid around that heat source would just get hotter and hotter and hotter. it wouldn't move because there's no gravity to pull down the colder, denser air. So how on earth can we move that warmer air away from the heat source? Well, we need fans. So we sometimes have to rethink how we can design machines. Examples of convection currents. Both pictures are useful, and just look at them and just see the similarities. Effectively, we see warm, less dense air rising, cool, denser air sinking and pushing the warm, less dense air up. Both examples you should be able to describe in an exam. Your turn. Okay, pause the video and try to answer the questions. The answers will follow. Okay, so I'm just going to say the word pause. Now I will give you the answers. When a fluid is heated, it expands, becomes less dense and rises. The warm fluid is replaced by cooler, denser fluid. The resultant convection current transfers energy throughout the fluid. This particular question is a grade C type thing, and it's the fairly basic ideas that we discussed at the beginning of this tutorial. Question 2, this is more a sort of A-starish or A-star question where you're actually having to use your knowledge in a slightly different situation. In this case, a computer is set up and uses convection currents to keep it cool. A. Why is there a metal grill at the top of the heater? That allows the hot air out of the computer. Where does air flow into the computer? If you look at your Xbox or computers, you should find grills at the side and possibly even at the bottom underneath the sort of little feet that hold it off the table, and the cold air comes in from the bottom. How can we increase the flow of air through the computer if convection currents are insufficient to cool the device? Quite often, although we do have a flow of air, the computer or electronic device gets extremely hot. You'll notice on your computer that there's often a whirring type noise. We use fans to blow the air, blow the warm air out or drag some extra cool air in. And D, what would happen to the computer if we failed to cool it properly? It would overheat. Circuit boards would melt, potential fires, an awful lot of hazards really. So many ideas for 1 mark there. So if you get 8 marks, then you're pretty much on course for the grade A. 3 to 4 marks a grade C, and something in between a grade B. So you can see the sort of standard we're looking at for this topic. Well, that is the end of this tutorial, so go through it again and just make your own notes and have a go at answering these questions. Just press pause. It doesn't matter, you can just listen to the answers. Okay, thank you, and the next tutorial will follow soon.